Welcome, everyone. We're in Las Vegas, and so there had to be a little bit of a magic show. For the folks who are going to be listening to the recording after, you'll have to know that there was a little bit of a visual element that added something. You can ask someone who was here. Now, I'll be your guide, me, Jeremy, on this mystical journey out of the monolith and into the multi-project verse. But first, ladies and gentlemen, I want to swear to you, in my honor as a practicing magician, amateur magician, that what you shall see here today shall be no trick, no illusion. It will simply be me and DBT. Let's begin. In the earliest days, a large DBT project would have 50 or 100 models. Over time, a new SQL select statement or Python data frame would add a little bit of complexity, and a little more, and a little more. There's no single mastermind behind this grand plan. It's the natural and organic result of lots of people, groups of people, many groups of people, getting their jobs done every single day with DBT. It's not anyone's fault, but it's a problem of scale. Imagine that I'm brand new at a company that's using DBT. And on my very first day, I load up a DAG of 200, 2,000 models without any clear indication of what's a well-governed, mature, well-maintained model and what's the building blocks on the way there. Oh no, don't use that one. How was I supposed to know that? So, what's the risk of this? Contributors are easily perplexed by which models represent mature, long-term interfaces, and which ones are merely the building blocks for getting there. The central data team begins bottlenecking the work of domain teams without drawing clear boundary lines over their ownership. Or the problem is reversed. In order to unblock themselves, teams start working in their own independent projects, meaning they start working in silos, walled off from one another, unaware of what the other may be doing. The challenge here can be organizational and technical if the reasons for those silos are because of different tooling, different data stacks, different data platforms even. This is a DBT model. It defines a transformation that produces a data set. Well and good, but it doesn't make any explicit guarantees about who owns that data set, how it should be used, what shape the data will take, how that shape may change over time. You see, it was into this world that 18 months ago, DBT Core 1.5 entered in April 2023 and brought with it new capabilities for governing DBT models. Now, thousands of DBT projects make use of model contracts, versions, access groups to designate and defend the models that represent mature data products. These are capabilities of the framework built into the open source standard of DBT Core. And now for my demonstration. You see, as a little bit of a side project, I'm starting a membership association of individuals interested in the practice of magic. You can see some of the founding team here. I'm very excited about it. Wizards, conjurers, SQL alchemists. It's soon to launch. And this members model is going to have a data contract defined. It has an owner, it has a set of columns, and their data types. And if I were to make changes to those columns, their names, their data types, in my model, maybe by going from Boolean to 0, 1 integer, or renaming a column in a way that makes sense to me, even in the moment, it doesn't mean that it makes sense to the person who had a query that depended on that name being what it was. Now, DBT will catch that breaking change for me, not just in prod, not just in CI, but right here in development. There's a mismatch between what I've defined and what I've explicitly guaranteed in my model contract. Should I want to, I can go and edit that contract and say, no, it really should be an integer, or it really should have that other name. But in so doing, I'm introducing a breaking change, one that I might want to do, or one that I might want to handle by means of model versions, to provide my downstream consumers with a stable interface and a migration path to go from V1 to V2. This is an API for data products within DBT. Because DBT has always taken inspiration from software engineering. This is no exception. API contracts and versions are a mechanism for people building software services to share curated information with one another in a stable and governed way. We believe that the same should be true for data teams, sharing data with one another, both within and outside of DBT. DBT Core, the framework, provides us with a standard way of defining models as well-governed interfaces, and dbt Cloud, the platform, provides the metadata that will enable me to show you my greatest trick, the transported model. You see, where once there was one dbt project, now there are two. We have Jeremy's Magic Club and Grace's Wizard Shop. For those of you who remember, you remember it well. Grace has graciously invited me to recruit among her best customers for new potential members of my club. Now, I could simply add more models directly into Grace's project. That's easy. But we're two different people, two different domains, two different lines of business. It doesn't make sense to tightly couple our work, our development and release cadence, just so she can share a data product that I might need to use as a building block. So instead, they shall remain two projects, one for each domain. For now, they are in silos, but they shall not remain so for long. We're going to stitch these two projects together along the lines of a well-defined interface boundary, dim wizards. I don't know the implementation details. I genuinely have no idea how Grace built this. I just know that it's a mature, well-governed data set that's ready for me to consume. And there it is. I'm going to do this with nothing more sophisticated than the simplest magic that every dbt novice learns on their very first day. The same ref function that allows one dbt model to select data from another one, now with two arguments, project name and model name. Let's take a look. And voila, through the magic of metadata in dbt Cloud, I can find the reference to that model simply by writing ref. I can preview the data, I can bring it into my own project, and then when I'm ready to push this into production, I can see the end-to-end lineage in dbt Explorer. At the project level, at the model level, and the code that's doing this is the same ref function that enables data isolation across environments, as well as end-to-end lineage across projects. Now, don't look too much behind the curtain. That was the easy part of my trick, if you'll believe me. You see, dbt Mesh is tackling a socio-technical problem. There's no shortcut to getting teams to collaborate with each other. I have no magic words or incantations or spells that will help you do it. There are real questions here. Where to draw the boundary line between projects, how to separate between business domains. But what we have in dbt is a standard framework, a single platform, and the building blocks of an opinionated pattern for how dozens, hundreds of people can be collaborating to use, reshape, and share the data they need. When it works, it can feel a little bit like magic. You just have to believe. And you'd be in good company doing so. There are now more than 150 dbt Cloud customers who are using dbt Mesh in production today to enable collaboration at some of the largest and most sophisticated data-using organizations in the world. And many smaller ones, too. For anyone here who thinks that it is only for those with thousands of models, hundreds of developers, and tens, dozens of teams, know that half of the folks using dbt Mesh today have fewer than 20 developers, fewer than 6 projects, fewer than 2,000 models. A quarter, it's fewer than 10 people, fewer than 1,000 models, fewer than 6 projects. This is a pattern that can take you to some of the largest, most magical organizations in the world, but it can also make sense from the very first moment that you look at your DAG and get that monolithic ick. In review, this is dbt Mesh. Model governance capabilities, contracts, versions, groups, and access in dbt Core for the last several versions. And cross-project references resolved via metadata in dbt Cloud. Mesdames et messieurs, thank you so much for coming. Merci. Avec ça, j'ai fini ma présentation. OK, thank you. Thank you. Thank you. Thank you. OK, all right. I think that's, I've got it. That's what I'm going to present at this year's Coalesce. What do you think, Anders? That's a good trick, right?
Give it up for Jeremy. You got to give it to him. Now, Jeremy, it's a great trick. We love the trick, right? It's magic. The transported model, dbt Mesh, we love it, right? But magician to magician, I have to admit, don't you think that trick's a little tired? Isn't this the same trick you showed here at Coalesce last year? Don't the people want something new?
Well, but when we presented for real, I mean, they won't all have been here last year. A lot of the people here probably won't even be using dbt mesh. They might not even know what it is. They might not even know that data contracts for dbt models have been in dbt core open source for many, many months, years even. I think it's worth repeating ourselves and making sure they really understand.
I think that's fair. And I hope everybody now knows about mesh and is excited to use it if you're a cloud customer. But don't you think they want to see something new? Am I right that you'd like to see maybe some more tricks?
OK.
How about that grand finale we've been working on?
No, they're not ready for that. No, they're not ready.
They're really
They're
not.
not
They're
ready.
not.
But I have a repertoire of other tricks that I've been working on. Anders, what catches your eye?
Ooh, now this is going to get him excited. Let's say, I'll bite. I think, tell me about private packages.
Oh, that's a good one. OK, folks, private packages. dbt mesh has provided a pattern now for sharing data sets across projects. Wonderful. As a well-governed, contracted API to access the data from that model, you simply write ref. But there's another kind of sharing in dbt today, for a long time, actually. Ever since there were macros in dbt, there were people writing cool macros, ones they wanted to share with their friends, their colleagues, people all around the world. Thus was born the dbt package hub. It made it very easy to install an open source package of utility macros. Add it to your project, it looks a little bit like this. But the same thing happens within a company. The central data team might want to share a collection of utility macros specific to their business with all the other teams who are doing dbt. It doesn't make sense to share this as an API for accessing data. It makes sense to share this as a library, as source code that can be pinned to a particular version, pulled down into the project, yes, with all the guts included. That code is generally private, internal to just that organization. Now, dbt Cloud already integrates with Git providers to clone down the source code from the primary project you're working in. What if it were as easy as this, a private package? dbt Cloud makes it that easy to copy code down from other repositories, ones with macros that you want to include as building blocks for your own projects. And I can take this trick one step further, if that wasn't enough. Let's say you started with a single project, a hub and spoke architecture. That hub is now supporting many domain-aligned data teams. And we can evolve macros from the hub project without needing to change any other lines of code in that project and still enable those spoke domain-aligned projects to use them too. Let's look. See, here, Grace has built a convert price to USD interdimensional currency conversion for all her magical wizard customers. And I'd like to use it in my own project too. I'm going to add a private package to my project, installing from the wizard shop, from the wizard utils subdirectory of macros that are ready to share. And then it's as simple as sticking that code right back in my own project so that I can convert to the appropriate currency, United States dollars, the membership dues of my various club members, wherever they may be coming from, whether Canada, France, or New Zealand. What do you think, Anders? Pretty good, huh?
You know, I got to admit, that was really cool. But I'm looking at the audience. They're not ready yet. I think we should do another one. You know what? Bidirectional project dependencies. That'll get them riled up.
OK, bidirectionals. Here we go. Here's the thing. We want to align projects to domains, not to slices of the vertical DAG. We have two projects here. Let's say our membership drive is a big success. My Magic Club is getting pretty popular, and we're ready to host our first in-person magical meetup. We need a place to host the events, and where better than Grace's wizard shop? I don't think so. In exchange, she wants to know who our members are so she can attribute her success, her sales, accordingly. Well, I'm using her wizard list to power my membership campaigns, which in turn drive traffic back to her store. Now, some of you may be looking at this and wondering, ooh, is that a DAG? I promise you it is. But it's a DAG that now exists across multiple projects. There are no node-level cycles here, and DBT will continue to detect those. Let's take a look. I've added previously the wizard shop as a project dependency to my magic club, and now it's time to add the magic club as a dependency for the wizard shop. Here in the fact orders model, in that wizard shop, I'm going to add a reference to the dim members model coming from the magic club, and you'll see it update in real time. You see it's still a DAG, even as dim members is actually coming from a different project from both dim wizards and fact orders. Pretty neat. Pretty neat. And yet you may have a question, haven't you, Anders? How am I going to orchestrate across two projects now that project A feeds into project B and project B feeds back into project A? Do I build A and then B, B and then A, B, B, A, B, A, B? If only there were some way to use the metadata about when models have been run, the freshness of the data feeding into them, to inform the orchestration of those models. Take fact membership campaigns. The right way to do this today would be with a mix of jobs and job completion triggers. But a better way would be to ask a couple of questions. Are all the inputs to this model fresher than the last time it ran? Has it been enough time since this model last ran? I don't want this to rerun every 5 minutes, even if there's source data feeding into it every 5 minutes. How is this model materialized? As a view that need not be rebuilt unless the logic has changed? In the coming months, we will be adding to dbt Cloud support for building models adaptively, where that means I can run a project of models, and for each model, dbt will decide, is it ready to run? I can even see which ones have been built and which ones skipped on the basis of new upstream source data, whether that data is coming from a real source or someone else's dbt model that I'm using as an upstream cross-project reference. That, Anders, is adaptive jobs and bidirectional project dependencies. What do you think?
I gotta say, that's pretty cool. Am I right? Give it up. You know, Jeremy, I'm thinking that this audience is ready for the grand finale. How about you?
Well, how about it? Okay. But I'm going to need your help, all right?
I think so. I think we're also going to need some help from the audience for this.
Oh, well, why don't we start? Places?
Let's go. Okay. 2, 1. Ladies and gentlemen, in a community Slack workspace for arcane magic, I heard tell of mystical powers that are embedded within floating masses of ice in the Arctic. Some people call this iceberg. Ladies and gentlemen, I've spent the last 6 months of my life seeking out this magic so I could bring it to you and show it to you today, here.
Anders, you should just tell them what iceberg is.
Oh yeah, you're probably right. Okay, fine. Let's talk about iceberg. Listen, I'm here to talk about, this is a very quick whirlwind tour here. It's a setup for the finale. But let's talk about iceberg. What is it? There's basically like 3 things going on, right? The first thing that you need to know, it's being adopted across the ecosystem and within dbt faster than any other technology, maybe apart from Gen AI right now in the data ecosystem. Second, the magic of it is that it allows data platforms to be both decoupled and interoperable. And 3, it's still emerging, still kind of new, and it's missing a key abstraction. Can we play a game really quick? Raise your hand if you had heard of Apache Iceberg before today. Okay, and now here's the game. Keep your hands up. Continue to keep your hands up if you answer yes to this next question. Raise your hand if you feel like you could confidently explain it to the person next to you. I had the next question. Raise your hand if you're using it in production today. Okay, still a few questions. And I saw some production people but didn't understand. So like, that's a good sign, honestly, right? That's me, I bet. So great, these are the 3 things. So we can look at like the ecosystem adoption. You can see on the right, we see a slide from Jacques Nadeau from Sundeck. It talks about the adoption of open table formats across various catalogs, proprietary and open source, as well as query engines. You know, the case is to be made that Iceberg is getting more adoption. We'll see more. Also, it's like Amy Chen already said in the keynote this morning, like we already see support for writing your tables to Iceberg table format within DBT today across like many adapters with more to come. Here's the really quick nitty-gritty. Like the goal of Iceberg when it's working is you don't have to think about this, but let's look at it, right? Like what is an Iceberg table? It's a folder in Object Store, S3, GCP storage, Azure Blob. And inside that folder, there's two folders. There's data, there's metadata. You can guess what the data folder has. The metadata folder, again, self-explanatory. Inside of that metadata folder is a metadata JSON file. It's got stuff like column schema, names, location, updated. That's all you need to know about the details. So let's keep going. When we talk about cloud data warehouses, I think it's really instructive to think about these 5 things: a query engine, a catalog, a table format, a file format, and object storage. And what do these do? Query engine does the work. You give it a SQL query, it returns you a little table. Catalog, it knows the tables. It makes transactions happen so you can roll back. It has metadata surfaced to the query engine. Great. Table format, we showed that to you. It's like, this is how it's stored, 2 folders. File format, that's how the data is formed. Like classically, it's Parquet. And object storage, you know, that's your bucket, that's your blob. So what I think this enables in Iceberg and what we're seeing is it enables this division between compute and storage, right? And like what I'm here to say is like for those of you who are like, I couldn't explain Iceberg, like walk away thinking like Iceberg is a great little abstraction so that users like analytics engineers like us don't need to think about these bottom 4 things. It's just something you go and ask. And as an example, let me show you this. Like who's ever used like external tables in SQL before? They suck. Like you have to define all the column types often if it's CSV. You have to give all these file format. Like that's not clean. Let's look at what Iceberg looks like. Look at that. There's no column schema. There's nothing. You just create this table. You give it the 3-part name of the catalog. You're done. When you're writing, same thing. Easy. Right? So here, this is what it enables. This is the lakehouse. This is something that maybe some of y'all are familiar with. Query engine A, catalog X. It just works. There's separation. But ladies and gentlemen, we're here for magic, right? Let me show you the future that I envision. This is what I see happening. Interoperable query engines and catalogs, cross-platform, if you will. And with that, Jeremy, I think we're ready. But we're going to need some help from the audience.
Who here uses DBT today with multiple data platforms? Please raise your hand. We need a volunteer.
Volunteers. We got a couple people here. You two here. Yeah, can you come up here, please? Yeah, come on up. Have a round of applause for the participants. Let's get the mics. Hello. Can you introduce
Hello.
yourself?
I'm Will.
And I'm Ulring. We are from Denmark. We work at Vestas. It's one of the largest wind turbine manufacturers in the world.
Another round of applause for our volunteers. Now tell us, Ulrich and William? Okay, tell us, Ulrich and William, how long have you been using DBT?
Ulrich introduced DBT in 2020, and we have been using DBT Cloud since then.
Great, and what data platforms do you use today?
Databricks.
Databricks.
Snowflake, yeah.
Okay, and why do you use 2 platforms?
Well, we adopted Databricks for data engineering and data science, and we adopted Snowflake for data warehousing. And we choose DBT as a tool on top, so we have one workflow. And yeah, now we want to make them work together.
Okay, they want to make the platforms work together. Okay, so I think that we're ready for the trick then, right?
I think so.
So let's say, pretend these are laptops, will you? Can you hold this? Ulrich, come over here, please. Stand on this side. Ulrich, let's say that this is your laptop with your upstream core data platform project, right? This is your central data team on Databricks, right?
And William, this is going to represent your downstream business use case on Snowflake. The use case like?
Plant data domain.
Okay, your plant data domain on Snowflake. Ready? Remember,
Databricks. Databricks.
Snowflake. Databricks. Snowflake.
Databricks.
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 Snowflake.
Databricks. Databricks.
Now, on the count of 3, the data is going to flow out of the Databricks project, across the room, and into the Snowflake project. Ready? Like?
Magic.
Like mesh. Okay, 1, 2, 3. And there we have it. Thank you so much. All right, get off the stage. Okay, thank you.
Thank you. Round of applause. The participants, thank you.
Sorry?
Yeah. What's wrong? We just
No,
now.
sorry, I just need to say I'm not really convinced. I mean, it's pretty impressive, but this is not magic.
What do you mean?
We already did this. At Vestas, we have cross-platform mesh working in dbt Cloud, and we're already using it in production.
Round of applause. That's impressive. That's magic.
Yeah. Our Databricks project. In our Databricks project, our public dbt models are materialized using Delta Uniform. So we generate the Iceberg metadata in that project. Then, on the Snowflake consumer side, we are using the Iceberg REST catalog integration to read the Iceberg tables from the Unity catalog. It just works. It's not magic.
Well, ladies and gentlemen, it's as I told you at the very beginning. There are no real tricks here. It's just me and dbt. Vestas is using cross-platform dbt mesh across Snowflake and Databricks today, along with a handful of other early adopters and design partners. I'm thrilled to say that the next evolution of the dbt mesh pattern extends collaboration from multiple projects and multiple teams to multiple data platforms. There's no magic here except the magic of a compelling abstraction and the magic of a liberal arts degree.
And it goes without saying, right? Cross-platform mesh is magic and real, but so is Iceberg. We believe that cross-platform mesh is the first use case that we think is enabled, but I think there's more to come. If you're interested to learn more about Iceberg and talk with your peers about it, I invite you all in this room to come join us, William, Ulrich, and myself, in a peer exchange on Thursday about Iceberg, and stay tuned for more updates to the upcoming beta for this.
In the meantime, you can check out the new and improved Mesh Guide Quick Start FAQ full of best practices and patterns from the hundreds of customers who are already doing this today. It's not magic. It might just feel like it. Thank you so much, ladies and gentlemen. You've been a wonderful audience.
Thank you.
Thank you, Vestas, as well.